In this lecture, we are going to start setting up our project. So I'm going to open up Visual Studio Code. This is the text editor I'll be using. I recommend you use this text editor to also write your compiler because it has some very nice extensions that you can install by here. So we're going to go and open a folder, and we're going to create a new folder here called Peach Compiler. That is what we're going to call our compiler, Peach Compiler. Okay, and we're going to press OK here, so it opens the folder, and yeah, we're going to start creating the source files now for the base of our project. So we're going to create a file called main.c, and I'm just going to zoom in for you guys so you can see the code a little better. So in our main.c file, we're going to create a main function. Okay, and we're just going to return 0. And we're going to create a Makefile here. So it's going to be called Makefile with a capital M. Okay, now this will be our Makefile for compiling our project. Okay, so we're going to go objects equals, and we won't put anything there for now. We're going to go includes equals -i dot /, okay, which will make the include directory relative to us. Now we're going to make an all label and a clean label. Now the all label will depend on the objects. Okay. And in here we're going to go gcc main.c-o dot / main. Okay, we're going to apply a -g for debugging symbols. We're going to have our includes by here, and that should be enough. So we compile main.c with the following include instructions. -g for debugging symbols. There's our output file, and we also need to have our objects as well. Just like that, okay? So that should work okay. So we're just going to include a file here. Include stdio.h, printf, hello world. So we're just going to check that that works, all right? So we're going to have to open a terminal and compile that. Okay, so we compile that by doing make. And there we go, that works. Perfect. Now we do main, we see hello world. We do make clean, we can see nothing can be done, so let's just add that. So make clean will remove the main file, and it will remove all of the object files as well. Okay. Be very careful with this -rf. Don't put a / or anything, or your whole system will be deleted, right? So just be careful with that. So yeah, we can do make clean. Nice. So that works. That works very well. Good. So that's now set up correctly. We're going to create a build directory here. Okay, and I tend to make a .keep file because I use Git repositories, and we obviously want the build directory to still be there. You don't have to do that. So yeah, we have our main file, Makefile, build directory, and that is our project set up. So going forward now, we can use this project as a base for creating our compiler. I also suggest installing some C extensions. So I'm going to just search for C, and you'll see C, C++ there. I'm just going to install that because these extensions really do help, guys, all right? So it's down there in the tab at the bottom left. And there you go, it's installed, nice. Okay guys, what we're now going to do is we're going to create some essential functions for our compiler to actually work. So what we're going to do is we're going to go to the Explorer, and we're just going to create a new file, and we're going to call it compiler.c. Okay, so this will contain some core compiler routines. So in compiler.c, we're just going to create a new function. It's going to return an integer, and it's called compile file, and it's going to take a file name and an output file name and also some flags. And we'll make these flags later. Let's just have the actual variable set for now. So essentially, once someone wants to compile test.c, they'll call the compile file function. They'll pass test.c in the file name here, and the out file name will be what you want to compile it to. So test.exe, for example, if you were on Windows. And obviously these flags determine how it should compile it. Are we creating an object file? Are we creating an executable? You know, things like that, right? So just in here, we're going to return 0, okay? And now what I want you to do is I want you to create a new file called compiler.h. And we're just going to go hashtag ifndef peach compiler h to find peach compiler h. And obviously it needs to be the same case. And I'm just going to hashtag endif there, okay? We're going to paste that prototype in there. So compiler.h will contain all prototypes for functions that need to be accessed throughout our compiler. All of them. It's going to be over 1,000 lines long when we're done, right? By having one header file that shares all the routines, we won't have to worry about having many header files and ensuring we include them all. Compiler development's difficult enough, so we want to make it as simple as possible for us to build this. Other things will be going here, such as structures related to the compiler, structures for tokens, nodes, stuff like that, right? So we now need to create a new file called cprocess.c, and this stands for compiler process, okay? And essentially we're going to have a function here, a couple functions for dealing with compiler process operations, such as creating the actual compile process itself, which will be a structure. So just go to compiler.h and we're going to go struct compile process, okay? And if we go back to cprocess.c, we're going to create a new function that returns a compile process pointer. And we're just going to call it compile process create. So this will create a new compile process, right? And we're going to go const char file name out, init flags, okay? Just like that. And I can just zoom out for you guys. So we're just going to include a header file, stdio.h. And here we're going to actually open the file now. So we're going to say file, fopen, file name, read. So yeah, if the file is null, we're just going to return null, right? Simple. So if we fail to open it, we'll return null because we can't create a compile process. So now we're going to make an out file name. That's just going to be the same thing. It's going to open it, but the file name out. And it's going to be a write. Just like that. And again, if we fail to create it, we'll return null. However, the out file name is optional, right? So we want to check that it exists first before we do this. So we'll go out file equals null by there. And just like that, right? We can right click format document. So yeah, so if they do not provide a file name out, then we will not open anything for writing, okay? Because sometimes you might want to compile something just to show on the terminal. You might not want to actually pass it out to a file, right? So that's what this is for. So now we're going to actually create our compile process. So we're going to go struct compile process equals calloc. And we need to include stdlib for that, guys. Okay. And it's going to be one member, size of struct compile process. So that'll just declare the memory and set the memory to null for us, complete zeros. Okay. And it says incomplete type not allowed. That's because we need to include compiler.h as well. Just like that. Okay, so we're going to go process flags equals flags. And we're going to have to create that actual variable. So go back to compiler.h. We're going to go init flags. Okay. And yeah, I'm just going to put a bit of a comment here for you guys. The flags in regards to how this file should be compiled. Okay. Comments are good. So now we want to create a substructure for the input file. So we're going to go struct compile process input file. And we're just going to call that a C file, compiler file. And that's going to take a file pointer and an absolute path. Okay, and we're also going to include stdio.h. So we can see here my IDE complains about stdio.h. Just ignore this for now. It's probably because we haven't actually put the compiler.c in the Makefile yet, so it can't resolve that header file. Okay, so now we're going to create a new file called file ofile, and this is the output file. Okay, where we're taking the input file. What is the output file we are writing to? Okay, so that should do for now. Let's go back to cprocess.c, and now we're going to go process cfile.fp equals file, and we're going to go process ofile equals out file. Okay, there's a lot more to initialize in regards to our compile process, but we'll add to it as we go along. Right now I'm just trying to get us the bare minimum required before we can actually start writing the project properly. So here we're just going to return the process. Okay, and now we're going to copy and paste this prototype into compiler.h, just like that. Okay, so now we just head back to compiler.c, and we're going to continue our compile file. So we're going to go struct compile process equals compile process create file name, out file name, and flags. And I need you guys to include compiler.h as well, guys. All right, and in the event there's an error, we're just going to return compiler failed with errors. And we're going to have to go to compiler.c to create that enumeration. So if we just go up here, we're going to go enum compiler file compiled OK, compiler file compiler failed with errors. Okay, just like that. And now you can see that we have that resolved correctly. And here we're just going to go compiler compiled OK rather than return 0. Okay, so by here we're just going to say perform lexical analysis, perform parsing, perform code generation, and we can add to this as we come along. But this is essentially what it's going to do when you call compile file. It'll pass your input file through lexical analysis through our Alexa, and it'll pass it through parsing to produce an abstract syntax tree, code generation, and so on, and validation as well, of course. So this is the root function for compiling any file, and it breaks it down by calling all the sub processes. Okay, so that's what will happen. So we're now going to add compile.c and cprocess.c to our Makefile. So go to the Makefile. So we're just going to go by here, and we're going to type /build compiler.o :/compiler.c, and then here we're just going to go gcc compiler.c -o /build compiler.o-g-c. And I do expect you guys to know Make for this course. I know that not all of you are going to know Make. If you have a IDE that creates the make files for you, you're more than welcome to follow the course on that. But I always make the make files manually. So if you are confused here, having problems with this make file, you should look that up. So you must use tab in make, no spaces, or that'll cause a problem, okay? So we're still not actually done here. We need to actually also include the includes, which will include this here, okay? So let's copy and paste that. And we're gonna change this to cprocess. Just like that. And now for our objects, it's gonna be ./build compiler.o ./build cprocess.o. So now we're just going to go to our terminal, and we're going to go make, and we can see it builds and links those successfully. So that's perfect. That works absolutely fine. I was just going to do make clean to delete them. Okay guys, we're now going to create some helpers. And the helpers will be things like vectors and stuff like that, buffers that can change size when you write to them. So create a new folder called helpers. And we're not actually going to write this code because it's very generic, okay? we're going to go to my GitHub and we're going to download those files. So just open up File, Firefox. And I'd also like to say, guys, that I'll also put a direct link in the lecture description here, okay? So we're going to go to github.com and we're going to search for Dragon Compiler, because Dragon Compiler was the project I made originally, my first C compiler, where a lot of these files are present. So okay, once this is loaded, you want to look for nibblebits/Dragon Compiler. That's the official Dragon Compiler that I've written before. And we're just going to go to the helpers. And here you can see so many helpful things. You see vector.c, vector.h. These are vectors and stuff like that that will really make the whole compiler process simpler. So we're actually going to just create these files. Okay, so let's copy and paste vector.c. And we're going to create that file in the helpers. Just going to paste it in. You're welcome to have a look and see what it's all about, but there's no point me teaching you how to write this because it's unrelated to compiler development. And we're going to go back to the helpers, vector.h, and we're going to copy and paste that. Okay, we won't be copy and pasting anything else, just these helper things. Everything related to actual compiler development will be shown to you from scratch. And we don't need hash map, we don't use that in our compiler. And you also don't need file.c or file.h, guys, so you can ignore that too. Just take the buffer. So we're going to go buffer.c. We're going to copy and paste that. Buffer.c. Awesome. Buffer.h. Copy and paste that. There we go. Nice. So yeah, essentially, guys, Dragon Compiler was the original C compiler I wrote in preparation for this course. So you can find a lot of helpful resources on the Dragon Compiler repository. Although you'll notice that I also have a Peach compiler repository, which is the repository directly related to this course. So if you want actual direct source code on a per lecture basis, check the Peach compiler. If you want to see the project I created prior to this course, Dragon Compiler. Awesome. So now we've got those vectors, buffers, and stuff like that. Let's add them to the Makefile. So we're going to go to the Makefile. We're going to go /build buffer.o /helpers buffer.c. Okay, we're going to copy and paste that. Helpers buffer.c build /helpers buffer.o, and we're going to create in the build directory here another directory called helpers. Okay, I'm going to create a .keep file there as well, just so because I'm using git. Okay, and we're going to copy and paste that and do the same for vector. And there we go. So let me just go over these for you. We'll go over the buffer. Essentially, buffers are when you have a string that you don't actually know what the size is, okay? It doesn't have to be a string, it can be any sort of data. But it will typically be used for strings in our compiler project. So buffer creates a new buffer. We can use buffer read, buffer peek to look into the buffer, okay? And we can call this to extend the buffer, or we can write straight to it with printf or write. If it exceeds the buffer boundary, it will increase the buffer for us automatically. Okay, so it's a very handy feature, right? So we can write to this as much as we want. It won't breach any buffer because the buffer will resize when you use these functions if it's needed. Okay, the vector will be basically store things. So you'll say something like, I want a vector of integers, okay? And then you'll be able to push or add integers to this vector, okay? So that's what that's about. So we're just going to see if this compiles. We're going to go make clean, make, and we can see there's compile issue. So we'll go back to the Makefile. And yeah, I can actually see the problem. We haven't added the objects here. So we're going to go build helpers buffer.o, build helpers vector.o, and you'll notice we also haven't adjusted it here as well. So it should be like that, yeah? Helpers buffer.o, helpers vector.o. Okay, so it should look like that. If we try that again, make, you can see that now compiles absolutely fine with no issues. Perfect. So I'm now going to show you the vector a little bit because we're going to be using it a lot. You need to understand how it works really, right? So go to main.c and I'm going to show you that here. So we're just going to go include helpers vector.c, vector.h I mean, and we're going to say struct vector vec equals vector create. So what does it ask for? It asks for a size. So if we're creating a vector of integers, we'll do size of init. Okay, so that makes sense. So now what we're going to do is we're going to go integer x equals 50, and we're going to go vector push, and we're going to do vec, and then we're going to go ampersand x, which is the address of x. Okay, so it's going to push that integer to this vector. Okay, so now if we change the value of x to 20 and we push again, you will see that we have 50 and 20 on the vector, okay? And now let's set a peak pointer. So what's a peak pointer? Well, essentially we can peek at any point on the vector and read from there. So we're going to go vector set peak pointer vec 0, and then we're going to go init ptr equals vector peak vec. So that will return a pointer to the value we push to the stack, okay? Because if we look at vector push here, it essentially copies the memory from the address here into the vector position, okay? And if we look at vector peak, we can see that calls vector at, which basically just gives us a pointer to the vector position, okay? So that is why we are doing vector peak, and it returns a pointer, okay? So now you can see why I wanted to show you this, because it is a bit of there's a bit of logic going on here you need to understand. So we're going to go while pointer equals vector peak vec, okay? So now what we're going to do is we're going to say printf %i, and we're going to print that pointer value. Okay, so now let's just test that. We're going to go make, and we're going to go main, and we can see 50, 20. Okay, so you can see it's gone through the vector with the elements we pushed, and it now outputs them. Okay, if you want to pop from the vector, then you just do vector pop. Okay, and you pass in the vector. So then we should only see 50 on the stack there, right? So let's try make again, main, and now we only see 50 because we popped off the 20. Okay, so that's a brief introduction to the vector. There's other functions that are part of this vector that I created. However, I hope you can see why we won't be writing all that functionality ourselves, because it's 500 lines long, and it's unrelated to compile development. So our vector will be used for storing things like tokens in memory and nodes in memory and stuff like that, right? So that's an introduction to the vector there. Okay, so before we wrap this lecture up, let's just call our function we created. So our compile file function. So we're just going to say compile file. We're going to have to include compile.h here, guys, as well, right? And then it's going to ask for the file name. We're going to do test.c, okay? And then our out file name will be test, /test, and we're going to have 0 flags. And we're going to have a response here. We're going to say if the res is all okay. I'm going to say printf, everything compiled, fine. Else if res equals failed, printf compile failed. we could be a bit cleaner with this error system, but this is all just template stuff for now, right? So we're going to say unknown response for compile file. Nice. Okay, maybe a switch and some function to handle that error would be more appropriate, right? But this is just template code for now. So we're going to say make clean, make, okay, we're going to go main, and we can see compile failed because there's no test file. So what we're now going to do, we're going to create a test.c file by here, and we're just going to make a stupid function that returns 0, okay? And now if we try that again, we can see everything compiled fine because it managed to open the test.c file. Okay, so the test.c file will be where we're testing all of our C code that we want to compile, okay? So test.c will be compiled into test executable, okay? That's how this is going to work, guys. And yeah, so we've got the template sorted. So in the next few lectures, we'll create lexical analysis, and we'll go from there to parsing and then eventually code generation. So I hope this wasn't too much for you. There is source code related to this lecture in the lecture description, okay? So yeah, you can see that we're breaking down the problem before we've even started writing any logic. And that's very important when you're developing compilers because they do get complicated. So we can see going forward, we're going to perform lexical analysis, parsing, and code generation. And there will also be validation here as well. So thanks so much for watching.